All right. This is the idea that we talked about yesterday. And it's a pretty basic idea about segments and the idea that the pieces of a segment should add up to the whole thing. So if I take this blue piece and this green piece, it should add up to the entire red piece, the entire distance from A to C. So yesterday, we talked about just using some simple diagrams and using it to set up some equations. That's what we did yesterday. Today, we're going to take that idea and bring it into some application problems. That's what we're going to work on today. So, first problem on the back. First problem on the back. You are traveling on a highway starting at Appleton, point A. After you have traveled 63 miles to Brighton, point B, you see a sign that says it is 87 miles to your destination of Clifton, point C. So part A says find the total distance you will travel to get to your destination. Okay, so this is the very bare bones idea of segment addition postulate that we talked about. To get the distance, we want the total distance to travel to get to your destination. So we want from the start, point A, all the way to where we end, point C. And to get that distance, we don't have the whole distance, but we do have the pieces. We have A to B, and we have B to C. So all we need to do to get the total distance is take the pieces of the distance that we have and add them together. So what's the distance? We got the distance from A to B. And we want to add the distance from B to C. That's what the segment addition postulate says we can do. And so what is our distance from A to B? It's going to be 63. And then our distance from B to C, it's 87. So we just take those two distances, add them together. 63 and 87, that's 150. Oh, there's something missing from that answer. It is miles. You got to make sure to put a label on the answer. 150 what? Miles. So that's part A. Part B. You are traveling at a constant speed of 60 miles per hour. How many hours will the entire trip take? And so this is a formula that you have probably talked about in a class before, which is distance equals rate times time. Distance equals rate times time. And that should make sense. If I want to know how far I went, I can take the average speed that I went and multiply it by how long I went that speed for. And that should tell me how far I went. So distance equals rate times time. So we need to find out, I'm going to give you a minute, and you need to tell me which pieces of these are given to us that we already know and what we're trying to find. So I'll give you a minute to do that. So two of these should have a number attached to them. One of them should have a question mark because it's what we're trying to solve for. Distance is 150. We just found what the total distance was. We just found what the total distance was, so 150 miles. That's one of the things we know. The rate is 60. The rate, or the speed that we're going, is 60 miles per hour. The time is what we're trying to find. And we know that we're trying to find the time because it's asking how many hours. How many hours is a time question. So that's the thing that we don't know. Look at what the question is asking if you're not sure what the thing you're trying to solve for is. Okay. So let's put those numbers in. Distance is 150. Our rate, we said, was 60 miles per hour times time. So we're going to solve by dividing. (150) divided by 60, that is 15 over 6. Reduce that, divide by 3, so that's 5 over 2. 5 halves would be 2.5. 2.5 what? Hours. We want to keep our units consistent. This was in miles, this was in miles per hour, so that means the time needs to be in hours. Make sure that's the other reason units are important. We want to make sure the units match up. The race is going to start at point A. It's going to travel along the path, and it's going to finish at point F. And so let's count. For part A, it asks how many miles is the entire race. So let's count along the track here. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Is the amount of boxes that we're traveling along this path. Again, this is a basic idea of if I combine the pieces together, then I'll get the distance of the whole thing. And so 15 is almost correct. It is correct that 15 is our distance of amount of boxes that we go. But we need to do something else to make it our final answer. Oh, that's something else. Oh, the measurements. The units that we travel. Here's the problem with 15. Is that our units, our graph, our scale is counting by 1.2s. So I shouldn't really count 1, 2, 3, 4, 5. I should be counting 1.2, 2.4, 3.6, and so on. So I'd take 1.2 and 1.2 and 1.2. And add it together 15 times. And because I'm lazy, I'm writing that out as multiplication. Because multiplication is just addition if you're lazy and don't want to write out adding 1.2 together all those times. 1.2 times 15. Which, as we said, was 18. Miles! I've had times where I get through the whole problem and no one calls me out on miles. So, good. Part B. Part B says how many miles is it from the start of the race to point C? So the start of the race, let's see, it starts at point A. And we're tracking to point C. So let's count. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9. And each of those was 1.2, so we need to multiply it by 1.2. It's going to be a decimal this time. 9 times 1.2, that's 10.8 miles. Part C. How many miles is it from point D to the finish line? From point D, here's point D, out to the finish line. The finish line is here. 1, 2, 3. Each of those is 1.2, so we're going to multiply it. 3 times 1.2 is 3.6 miles. Part D. How many miles will be eliminated from the race if the runners were told to turn left at point 6, 4.8, and then head straight for the finish line? 6, 4.8. So first, I want you to find that point and put it on the graph. Here is your hint. This point should be on the track. You counted over 6, which normally would be a very good thing to do. I count over 1, 2, 3, 4, 5, 6. But when I'm counting where to put the point, I don't want to count 1, 2, 3, 4, 5, 6, do I? I want to count by 1.2s because that's what the scale is on. So what I want to count is 1.2, 2.4, 3.6, 4.8, add another 1.2, and we're at 6.0. So 6 is here. And then 1.2, 2.4, 3.6, 4.8. Here's the point. Turn left, finish line. So here is the new path. The new path goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times 1.2. If I were scoring that answer out of 5, that answer to part D so far, I'd give it about a 3.5. It's pretty good. It's on the right track. It's missing some things, though. What's it missing? Well, it's missing miles. Okay, now it's got a 4 out of 5. It's missing something else. Read the question again. It's asking how many miles would be what? Eliminated. I found the distance of the new path. This is the new path. So I've got the distance of the new path. I've got the distance that I traveled originally. So to find how much I eliminated, how much did I get rid of, we're going to subtract. The old course was 18. My new course is now 13.2. So if I subtract those, I should be able to tell how much I got rid of. That means that the difference between those is 4.8 that I eliminated. Miles. So this is our final answer. Here's another way you can figure this out and keep track of exactly what got eliminated. Is I can actually look visually between the old course and the new course and see what I got rid of. So what is missing from the blue course that was in the original course that I had? Well, blue. I still travel along this path. I still go up here. I don't go up here anymore. Then they move 3 boxes to the left. Oh, but I still do that. I just do it down here. So I still travel 3 squares, but I just travel 3 squares in a different place. So that's not really gotten rid of, that's just gotten moved to a new place. But I don't travel down here anymore. And then I still finish up by moving a box to the left. So these 2 boxes going north and then coming back south each are what is eliminated. How many boxes is that? That's 1, 2, 3, 4 times 1.2, 4.8. There's the 4.8 miles that got eliminated from the track. So we can actually visually find them. This problem I'm going to be asking for you to do on your own. And I will be checking that it's done when I check the notes later today. You're going to use rate times time equals distance again. And the thing that you need to work on and get is a distance, because it asks how much farther. That's a distance question. So the distance is going to be the thing that you're going to use this equation to figure out. And I'll let you think about how that distance is going to be used. One more hint for you. Remember, I've been talking about how important units are. I've been talking about how important units are along that line. I don't want to use 90 as my time. 90 should not get plugged into your time. A different number should get plugged in for time, because the units are important. And I'll tell you that if you do it correctly, your final answer, your final answer of how much farther you need to go to the end. So you figure out how far you've gone so far, you figure out how long the entire path is. How much farther do you need to go? Your final answer should come out to be 3.1 miles. That should be your final answer.